Good day everyone, I'm Adeline. First of all, let me briefly introduce the person in charge in this project, which are Paisin and Michelle. So, let me start by giving some background information for the project. The fourth industrial revolution, or Industry 4.0, has significantly transformed logistics management by integrating technologies such as blockchain, AI, and big data analytics. These technologies enhance efficiency, transparency, and sustainability in supply chain operations. However, challenges like high implementation cost, data security concerns, and the need for skilled resources hinder their widespread adoption. Our study examines key frameworks that highlight how Industry 4.0 can be effectively implemented in logistics, focusing on sustainability and operational excellence. Let me now discuss the first three critical frameworks analyzed in our project. The first one, Farouk in 2025. This framework emphasized the role of environmental dynamics in driving the adoption of Industry 4.0 technologies. It highlights how these technologies foster green supply chain collaboration and circular economy practices, ultimately enhancing sustainability and technological readiness. For the pros, this framework integrates sustainability through collaboration and circular practices while emphasizing adaptability to dynamic environmental changes. For cons, it oversimplifies the relationship by assuming a linear path from technology adoption to sustainability, ignoring complex interactions such as regulatory and market dynamics. The framework number 2 is by Agostini and Nocella in 2020. This framework focuses on the impact of investments in advanced manufacturing technologies and the role of social capital in facilitating Industry 4.0 adoption. It highlights how internal and external collaboration, along with absorptive capacity, influences the successful implementation of these technologies. For pros, it provides a holistic view by integrating technical, social, and organizational factors, making it adaptable for various industries. For cons, the abstract constructs make it challenging to apply practically, and the framework does not adequately address external factors like market conditions or regulatory hurdles. Next, I will evaluate the selected framework by Khan in 2024. This framework examines how Industry 4.0 technologies influence green supply chain management practices (GSCMP), affecting both operational performance and green innovation performance. It emphasizes the dual role of Industry 4.0 in improving efficiency and driving sustainability. The framework effectively connects technological advancements to both operational and innovation outcomes. It highlights the importance of integrating green practices with Industry 4.0 technologies. For the cons, it lacks specificity in defining Industry 4.0 technologies and overlooks moderating factors like organizational readiness and market variability.
We found the framework from the article of link between Industry 4.0 and green supply chain management evidence from the automotive industry. This framework helps us leverage the advantages while identifying the potential limitations and enabling us to address the challenges more effectively. From this framework, we can identify the integration of Industry 4.0 technology, which include IoT, robotics, blockchain, big data analytics, with green supply chain, GSC, and practices to enhance the performances. First of all, the advantages is to combine the green and technological innovations for economic, environmental, and also operational performances. Next, ensures the flexibility with technologies like blockchain and IoT. They also have some disadvantages from this framework, which is presumes linear relationship ignoring real-world complexities, lack considerations of external factors like regulations and market conditions, and also overlook costs and challenges of adopting advanced technology. This framework is taken from the article of the role of Industry 4.0 and the Ambidacity on the SCM SME performance link, Australia evidence. Based on this framework, we can identify the interrelation of ASEAN implementation, Industry 4.0, and Intercity and SME performances with significant mediation effect of Industry 4.0 and Intercity. They have some pros based on this framework, which is comprehensive approach to SME performances improvement, identify the specific areas for targeted strategies relevant in the context of digital transformation. They also have some disadvantages based on this framework, which is complex relationship require extensive data and advanced analytics, assume the linear impact of SCM and SME performances, ignoring dynamics, and also excludes the external factors like market conditions and organizational culture. In this slide, we found this framework from the article The Impact of Applying Knowledge in the Technological Pillars of Industry 4.0 on Supply Chain Performances. Based on this framework, we can explore how Industry 4.0 technology impact the supply chain and organizational performances, emphasizing the knowledge-driven innovations. There have some pros based on this framework, which is highlights the importance of knowledge-driven innovations for the competitiveness. Simple structure makes it easy to understand and implement. They also have some disadvantages from this framework, which is simplicity of complex interactions between the technology and performances, used to address the feedback loops and external factors. And the last one is to overload the cost, resistance, and training needs for the Industry 4.0 adoption. Next, we also found this framework from the article The Impact of Industry 4.0 on Supply Chain Capability and Supply Chain Resilience, a Dynamic Resources-Based View. From this framework, we can examine the impact of Industry 4.0 adoption on IT capabilities, supply chain cooperation, visibility, resilience, and competitive advantages. There are some pros based on this framework, which is links Industry 4.0 adoption with IT and supply chain capabilities, and also provide a clear path toward resilience and competitive advantages. There are some cons based on this framework. The first, the first link is oversimplifies the complex supply chain relationship, and the last one is ignores the barriers like cost, resistance, and sustainability challenges.
Greetings, I'm Michelle and I will explain the recommended framework. The independent variable is the adoption of Industry 4.0 technology, which includes IoT. IoT enables real time tracking, monitoring, and data sharing across the supply chain. Next, we also have blockchain technology, which enhances transparency and security in supply chain transactions. And last one, AI, which drives advanced analytics, predictive decision making, and automation. Going into the mediators, which explain how IR 4.0 adoption can impact logistics performance. The first one, circular economy practices. IR 4.0 technology can facilitate sustainable operations by promoting waste reduction, resource optimization, and recycling. For example, IoT sensors can monitor material usage, while AI can predict and minimize waste generation. Next, GSC or Green Supply Chain Collaboration. Collaboration between supply chain partners can be enhanced by technologies like blockchain, which ensures trust through secure data sharing, and IoT, which enables real time updates on shipment status. We also have digital integration. Digital integration is connecting systems and data across the supply chain. So, if we implement AI powered tools and IoT devices, companies can achieve seamless communication and better coordination among logistics players. And lastly, we have organizational agility. Agility is being able to move quickly and easily. So, in today's age where the industry changes rapidly, IR 4.0 adoption enables organizations to respond quickly to changes. Technologies like AI will support scenario planning and automation. Other than that, we also have some moderators which influence how strongly IR 4.0 adoption affect the mediators. Firstly, we have management support because management is responsible for allocating resources, fostering a culture of innovation, and aligning organizational strategies with technology driven goals. Next, we also have environmental dynamism because of dynamic market conditions such as regulatory changes or fluctuating demand will influence how IR 4.0 technologies impact logistics performance. Ultimately, the goal of this framework is to enhance logistics performance across four key dimensions: sustainability to achieve lower carbon emissions and waste through circular practices, and efficiency to reduce operational costs, resilience to strengthen the organizational ability to recover from disruptions, and to achieve customer satisfaction by meeting or exceeding customer expectations. In conclusion, Industry 4.0 technologies such as IoT, blockchain, and AI are transforming logistics, as we have already discussed in our introduction. These technologies provide the foundation for improving efficiency, sustainability, and resilience in the supply chain. From our literature review, we saw how these innovations enhance real time tracking, predictive analytics, and trust across the network. However, challenges like high costs, data security, and skill shortages remain. Our discussion highlighted key enablers like circular economy practices, green supply chain collaboration, and organizational agility, all of which are supported by Industry 4.0. Together, they create a framework for defining logistics performance. Ultimately, the adoption of Industry 4.0 technology is not just a choice, but a necessity for businesses aiming to stay competitive in a rapidly evolving global landscape. Thank you.